Welcome back to The Explainer, brought to you by Forge College. Look, if you've been following along, you just absolutely crushed our last capstone. Building that token management system using the Solana CLI. And man, getting those deployment scripts to run properly feels amazing, right? But let's be real. As your projects start to grow, tracking all those files gets messy fast. So today, we're going to dive right into the foundations of version control with Git.
Okay, here's our roadmap for today. First, why do we actually need Git? 2. How commits are basically just snapshots. 3. The staging area cart. 4. Branches as parallel timelines. 5. Merging and resolving conflicts. And finally, number 6, choosing a branching strategy. All right, let's just get right into it.
Section 1. Why do we need Git? We're calling this the deployment dilemma.
Okay, we have all been there. It is 4:59 p.m. on a Friday. You run your Solana deployment script, and boom, just red errors everywhere on your screen. Total panic sets in, right? You're wondering, who changed the configuration variables? Was it Dave? Honestly, it's usually Dave. The thing is, without version control, you're just flying blind. You're desperately trying to remember what that perfectly working file looked like literally just yesterday.
Well, that is exactly where Git comes to the rescue. Think of Git as basically the ultimate, all-powerful undo button and history tracker for your code. Technically, it's a version control system that meticulously records your project's history as a sequence of commits. So for your Solana workflows, it's tracking every single shell script, every tiny keypair file update, and every deployment note. It definitively answers who updated a configuration, why they did it, and most importantly, how you can instantly revert back to a safe working state when things inevitably go wrong.
Moving on to Section 2. Commits are just snapshots, capturing the moment.
So a lot of beginners kind of imagine that Git stores diffs, meaning it just records a little list of line-by-line changes like added line 5, deleted line 10. But actually, that's not true at all. Git stores snapshots. I want you to think of a commit as a standalone photograph of your entire project directory at that exact moment in time. So reverting doesn't require doing all this weird backward math to undo a bunch of lines. Git just pulls out the older photograph and perfectly matches your working directory to it. This is exactly what makes reverting to a prior working Solana script incredibly fast and honestly highly reliable.
Now, under the hood, this snapshot system is just brilliantly engineered. A commit points to a tree, which is essentially the state of your directories. That tree then maps to blobs, and those blobs hold the actual file contents. And the really cool part? These blobs are identified by content hashes. Because it uses hashes, if a file hasn't changed between two commits, Git doesn't just save it twice. No way! It just reuses the exact same blob object. It literally deduplicates automatically. But listen, this is exactly why you absolutely must use a gitignore file to exclude large Solana binaries or, temporary keypairs. Because if a compiled artifact changes even slightly on every single build, Git is going to save a brand new massive blob every single time, and that will absolutely bloat your repository history.
Okay, Section 3. The staging area cart. Preparing your order.
Enter the staging area, which you might also hear called the index. I really want you to imagine the staging area as your online shopping cart. When you're just editing Solana scripts in your working directory, it's kind of like you're just browsing the store aisles. Your edits are sitting completely outside of your Git history at this point. You have to intentionally take an item off the shelf and place it into your shopping cart, and that action right there, that is staging.
This multi-step workflow is honestly a superpower. You edit your scripts, you add very specific files to your staging cart, and then you check out to create the final commit. So let's say you fix a critical bug in a deployment script. But while you're in there, you also cleaned up a bunch of messy white space and formatting. Well, instead of dumping all of that into one chaotic update, you can stage just the bug fix and commit it. Then stage the formatting cleanup and commit that entirely separately. It creates this beautifully clean, really easy to read history for anyone who has to review your code later.
Section 4. Branches as parallel timelines. Diverging lanes.
So try to visualize branches as parallel timelines, or maybe lanes on a highway. You've got your main timeline, right? That's the production lane, where your stable, working Solana code lives. But let's say on day 2 you want to experiment with this slightly risky new automated deployment script. Well, instead of doing that in the main lane and risking a total crash, you diverge. You just create a separate feature timeline. You can go break things, test wild new ideas, and experiment totally safely over in that lane. Then, maybe on day 4, when the script is finally perfect, you just merge that timeline right back into the main lane.
And honestly, here is the secret to why branching in Git is just so universally popular. A branch is not some heavy, completely separate copy of all your files. Not at all. It is literally just a lightweight, movable pointer to a specific commit. It simply tells Git where the head of your work currently is. And because they're just pointers, branches are incredibly cheap and practically instantaneous to create. You really should be using these quick, cheap branches constantly for fast iteration.
Right, Section 5, Merging and Resolving Conflicts, Converging Timelines.
When it's time to merge, Git actually does some pretty quick detective work. First, it finds the lowest common ancestor. That's basically the exact point where your lanes originally split. Now, if the main branch hasn't changed at all since you left, Git performs what's called a fast forward. It just slides the pointer straight ahead to your new work. Easy. But if both lanes have new commits, Git weaves them together into a merge commit, basically combining the two parents into a directed acyclic graph, or DAG for short. Now, usually, Git is smart enough to automatically combine everything perfectly. But if two lanes change the exact same lines of code, that's when Git throws its hands up, creates a conflict, and basically says, "Hey human, I'm just a program here. I really need you to figure this part out." So resolving that conflict is really both a technical task and a communication task. You'll literally edit the file to choose the correct code, stage it, and then just finish the commit. But hey, here is some absolutely critical, practical advice for you. Always test your merged configurations in a local test validator before you push them up to a shared branch. Solana environments often have super-specific variables or strictly ordered script dependencies. A script that worked absolutely perfectly in your own isolated branch might actually need a little bit of adapting once it's completely mashed together with someone else's updates.
Moving to Section 6, Choosing a Branching Strategy, Structuring Teamwork.
So teams use these frameworks to decide when to create lanes and when to actually merge them. The feature branch strategy isolates every single new issue into its own separate branch. This is great for clear code reviews, but it definitely can cause some integration friction if those branches stay open way too long. On the flip side, we have trunk-based development. This involves continuous, really small commits directly to a shared branch. It integrates blazingly fast, but it does require you to use things like feature flags to hide unfinished work. Finally, Gitflow gives you a highly structured history that's perfect for formal releases, but man, it comes with some heavy process overhead. For most Solana engineering teams out there, feature branch and trunk-based models are definitely the heavy favorites, mostly because they allow for those extremely fast feedback loops that are just absolutely necessary in Web3 development.
And that brings us to our conclusion and next steps.
If you walk away with literally anything today, please let it be these core foundational principles. Treat your commits as full, reliable snapshots of your project. Use your branches constantly. They are cheap, isolated lanes for you to experiment in. Treat your staging area like a super deliberate shopping cart so you can group logical changes together. And remember, making small, tightly focused commits is hands down the absolute best way to reduce those really pesky merge conflicts. If you adopt these mental models, your Solana CLI artifacts are going to become incredibly easy to audit, completely painless to roll back, and just seamless to hand off between your team members.
So I'm going to leave you with this one question. How will you organize your next big Solana repository? Are you going to stage your changes with real intention? Are you going to let your history turn into just a totally chaotic mess? Well, we're going to explore exactly how to read that history in our next lesson. Until then, be sure to visit forge.college to learn a whole lot more about version control and to dive even deeper into Web3 development. Thanks so much for hanging out for this explainer by Forge College. Keep building, keep committing, and I will see you next time.